deal with. Even all stuff such as probability, high school probability can be very useful. We all know this relationship. The probability of x and y can be written in two ways. Probability y multiplied by probability x given y. That's the middle equation, middle expression. The rightmost expression is what? It's similar, right? Probability x and y is equal to probability x times probability y given x. We all learned this in high school, I hope. Once you know that expression, you write this expression in a different way. The next line, the probability of x given y now is equal to something times probability x. This expression is the same as the other expression, right? Where's my? This one is the same as that one. This is the high school math. This one should be high school math too. This one is terribly useful. Basically says that this is the prior probability of x. After something y happens, this is the new probability of x. The new probability for x is posterior probability. This probability is equal to the prior thing times something here. Wow, this is a big deal. So you want to find out the most up-to-date the probability of certain event can be written as the previous probability times something. This is called Bayes' rule. Okay, such a simple thing, but it's so important. I tell you why. We use this all the time. This Bayes' rule says, for example, now you can compute the probability of a hypothesis given y in terms of probability of y given hypothesis. You see, I flipped this x and y around. I really want to compute the probability of certain hypothesis. I say this color is red, given y. But to compute this could be very difficult because of how do you compute the probability of hypothesis given a certain event. Instead, you can do this now. You can flip this x and y around. You see, now before x is in the left, now x is in the right. You can compute the probability of y given h, given hypothesis. Given a hypothesis, you can do sample under that hypothesis. So suddenly I can compute this thing given this. This could be useful. For example, suppose there's an accident. Eyewitness says there's a hit and run accident. The eyewitness says the taxi cab which made this accident is red. And suppose such a report has accuracy on average 80%. So usually you will trust a guy who say the color is red. You think it's 80% that guy is correct. That's a reasonable assumption, right? Unless the guy is a color blind. Usually you think the guy's word you can trust, right? Like 80% should be at least an 80% chance. So the judge says, 80%. You drove a cab that day at that time. You drove a red cab. We put you in jail because somebody said they saw that the taxi was red. Because 80% is so much larger than 50%, right? So the judge will make a decision based on this very accurate number, right? 80% is higher than 50%, so I'm going to say that guy hit hit per person. It turns out the judge is totally wrong. 80% is not 80%. Actually, the real number is 50%, maybe even lower. All depends on what's the probability among all the caps. How many caps are red? How many caps are other colors? If only 20% of the caps is red, then suppose, don't say 20%, suppose only 0.1% of the caps red. What's the chance a guy will see a red cap? No matter how good the eye is, that person's eye is, the chance is very small. The problem is the judge forget that there's a prior here. If you put the prior here, the whole number is still different. 80% become a 50%. The prior probability that the cap is red color is only 20%. Very, very small. Because judges don't know priors. Apparently in the US, a lot of court made mistakes. They did not learn high school mathematics. Okay, this is very serious. High school mathematics we don't even know. We sentence people because the guy just didn't learn high school math. Of course they learned high school math, but they did not understand high school math. They forgot prior. Prior is important. This start making you humble, right? Give you some more examples to make you even more humble later on. You know, we all get hurt because the spam email. Spam is terrible. But finding spam, given an email to decide if that email is a spam, it cannot be easy, right? Indeed, it was very hard for a long time. Until one day people figure out that this problem really should be handled by high school math. So, in order to find out what's the probability that email is a spam, given the email has certain word W. Okay, look at the email if you want to decide what's the probability the email is a spam. Very hard, but you turn this around. Now you instead of computing the probability of spam given a word, okay, you are going to compute for a spam email what's the probability that email contains that word. Then you can collect millions of the spam email and counting number of words, counting the frequency of those words appear in those spam email. The right-hand side stuff is computable. The left-hand side stuff cannot be computed. The left-hand side stuff asks if an email is a spam based on the email's words. The right-hand side says the other way around, says, what's the chance a given word appears in a spam email? These are two different things. It turns out once you write things in the right-hand side, you can compute. That's how people find spam email today. That's the reason you use Gmail, for example. Gmail can find all the spam for you, mostly due to this. So it doesn't mean that we need to use very difficult mathematics, but we need to how to use them. Give you